So cool. Well, first of all, yeah, I'm gonna take it easy here. Like it's about relaxing and enjoying all of us. So something I want to say is just feel free to interrupt me whenever you feel like. The idea is like to exchange thoughts here. Um, for all of you who don't know me, so here's the first issue. It's just like this was not the original font, and for some reason something happened. But yeah, my name is Fernando Cejas. Yeah, I'm basically here to share all the disasters I made as a developer. I think we all made mistakes, and it's always nice to share that too. Um, I That's my Twitter. It's at Fernando Cejas. So I use Twitter mainly for posting technical stuff. So if you're interested in any other shit that I post, then you can go somewhere else on other networks that I use. I try to keep up to date a blog where I share my experiences as software engineer in general, mostly Android development. Um, a little bit more. So I come from Argentina. We still don't have representation in Street Fighter, so I'm fighting for that. So I asked the creators to add our country there. Um, so the reason behind this talk, I've been giving this talk for a few times actually, and I've been collecting a lot of feedback. I've been talking to other developers. It's super nice, how you can evolve a talk. And if I've already seen it, probably you will find, some different stuff here. So in order to get started with our main topic, I wanted to share with you. This is a picture of of all of us, like my sister, me, and my mother. And like when we talk about multi-threading, right? This is like a taboo topic many times, right? So I was actually sitting there, and we were grabbing a beer, and then I just asked myself, and why don't I ask this to my mom? Like, Mom, what is multi-threading? And she said, okay, my son, you're not prepared for listen to that answer. So it's something complicated, or at least on paper. So she said, like, maybe the force of multi-threading would you just steal yourself, right? So sit down in front of a computer, of a whatever idea you have, and try to come up with something. So that's why I decided. I think most of the time we listen to the concept of multi-threading as being something very complex. And if you get some codes in the internet, it's always the same thing. Multi-threading is hard. Yeah, you had to redesign your apps to run in multi-threading environments and run things in parallel and things like that, right? The wall is there, especially with all the hardware that we have nowadays. We are not fully taking advantage of all these multiple processors that we have in our mobile devices and all kind of devices which are super powerful. So something else that every time that I prepare a talk, I like to, let's say, explore or try to compare a little bit, how things work in the human side. And I had to say that after some investigation, we are not multi-thread. We are not multitasking. So I know that many of you might consider that you can be multitasking, but it's not true. I mean, there's a proof actually. There's specific things that we can do in autopilot. Like, for example, now I'm moving and I'm talking, or sometimes we are driving and we are talking, or we are listening to a conversation. But when it comes to texting, then there's more things involved there. And that's why there are so many accidents, because our brain cannot process these complex tasks at the same time. So it's curious, because what we do, or what happens, is like we're constantly changing in our brain. The frontal part of our brain is what handles all these tasks. And we are switching contexts super fast here. That's the way it works. there's of course people who are better at this, and people like me who are super bad at that. But we are not multitasking. But what happens? Computers are, definitely. So, and here comes the first question. Oh, I'm gonna sit down a little bit. Um, so, yeah, when I started, investigating deeper, all these concepts, then, there was a question around: is concurrent the same as parallel? What do you think? Is there any difference between concurrency and parallelism? No. Yes. Yeah. Right. Okay. So what could be? I mean, what is the main difference actually? Let me put it this way. So basically, there is a clear definition here, but to put it simpler, let's say like if we were here to write, I don't know, letters all together, at the same time, same letters, because we need to speed out letters. We are running things in parallel because we are all doing the same thing. But that doesn't mean concurrency. Concurrency is about dealing with multiple things, different things. So that's why nowadays, pretty much all our devices or computers allow us to do things concurrently in parallel. So it's important to differentiate that, because we will see that sometimes we can do, I don't know, we can come up with some parallelisms without being concurrent. This talk is about threading. I want to go through specific things. I know I've been talking actually with some people here, Mac developers, iOS developers. I think most of the things that I'll be mentioning could be applied to pretty much any software engineering project, or at least you can get some ideas. That's why I'm going to be talking about threads and logs. RxJava, which could be also, it's a framework, it's a library. But yeah, I will get back to it later. And Kotlin coroutines. Coroutines is not something that exists only in Kotlin. It comes from other programming languages. And the reason why this is not about Android specific is because I don't want to depend on the framework to do specific things. I'm a person who prefers to abstract, to run away from the framework for testability and for many other benefits that we have seen over the years. So I'm not going to be talking about async tasks, handlers, and job scaler, all these beautiful things that we have on Android, right? Important here. Let's review a couple of concepts, super fast, only so we can understand each other when I mentioning something. Like a process, of course, is an instance of a computer program. Let's think about it this way, super concise and simple. That's it for now. Thread, it's a kind of a task. It's a small amount of instructions which are executed, and it is managed by a scheduler, which is part of the operating system. That's it, a task. Let's say a thread equals a task for now. Mutability. Mutability is something that we are, as developers, we are aware of. And when we have mutable state, it's not good for multi-threading environments, especially because of sharing state and inconsistent state and so forth. So mutability should be something that should be avoided when we're working with multi-threaded environments. Deadlocks, and these three things are special conditions or situations that could happen when we are dealing with multi-threading. So a risk condition, a deadlock is basically two threads are blocked forever. So there is something, one depending on the other, and they cannot make any progress. So they are blocked. And a race condition is like when there is a shared resource, like for example, and many threads or two or more threads are trying to modify it, and there is a lot of inconsistency between that shared state. And that's what I was talking about mutability. Also, starvation. Starvation, let's say, it's kind of like in a meal. Starvation is like sometimes we have two threads, and depending one from the other, and the first one probably is taking so much time in I don't know, retaining some kind of resource, and the other one is not able to make progress. So it means it's slowing down other threads. So just a quick since the code here is going to be Kotlin, I hope everyone is familiar, or pretty much everyone is familiar with Kotlin or Swift. They're very similar in the essence. But and this is basically wanted to give like a quick introduction on how Android works when you open up an application. I think iOS is the same thing. It's pretty much the same, but keep in mind that there's always a main UI thread, and we need to get out of the main UI thread always as a good practice, and do our background stuff, and then come back to the UI thread in order to print out stuff, so our users can interact with it. So many people ask why multi-threading. And we say, yeah, of course it's important to understand the fundamental, because that's going to give us more skills in order to solve our problems. So we have like a wider, bunch of problem-solving, solutions. But the reason behind multi-threading is because we want to be more responsive, within our apps. We want to use resources in a better way. And sometimes, and this could be a little bit controversial, and many people might not agree with me, simplicity. By just like dividing big problems into smaller ones, by using a divide and conquer approach, then that could be really simplify our code, and we will see it later. So, in order to get started, I put a problem and I started researching writing code. Because from now on, there's going to be some code, not probably a lot, but a big amount, a decent amount of code. So this is my problem. I decided, okay, I'm gonna grab some Wikipedia information. You can go to the Wikipedia page and dump all the pages or whatever pages you want and put them in a file, an XML file, okay? So it's important to understand or to remember what we are trying to accomplish here, what we are trying to achieve. So what we are saying is like, we're gonna grab a couple of files, XML files with Wikipedia pages. We're gonna go through each of those pages, grab its text, and we're gonna count it. Count how many words we have here. Simple problem. Why XML? XML is always, it takes time to parse and so forth. And we're gonna go, with all the examples are on my GitHub account. So you can go there and check it out yourself and run them. I run this on a mobile device, then I'm gonna get back later. I run it in my computer as well. But it's gonna be code, standard code. It has nothing to do with Android, but it was easier for me to just use a device there and deploy everything and run that. So again, remember, Wikipedia page, loop through each page, grab the text, and count words. Let's see things. Okay, in my defense, I'm a strong believer of like first make your code work, then make it right, then make it fast. If it isn't fast enough. But make it right here is not right, because I wrote really dirty code in order to, for learning purpose actually. So let's see. We have our problem. Let's start solving it. Let's get started by using threads and logs. Threads and logs, everything related to multi-threading is going to end up with threads and logs. We have abstractions. We have like so many things that, libraries which make us our life easier. But in the end, it's important to understand what's really going on with threads and logs. So I decided, okay, I'm going to solve my problem, like trying to parse all this and counting all these words by using threads and logs. piece of code. I don't want you to understand every single detail here, but I'm going to go through it super quickly. So what I'm saying here is like, okay, I have a hash map here, which is going to store the counts for each word. This is a super nice Kotlin function, which returns the time that takes, to execute a block of code. So this is the interesting part. I'm creating a thread. Don't pay attention to these numbers, but like keep in mind, I'm creating a thread here. I'm parsing. Remember that I have 2 XML files with Wikipedia pages, and then we're going to see why. So first, bunch of pages, looping through each page, grabbing the words, and for each word, counting it. Getting here and use the map to count it. Super simple, right? One thread. And I'm starting right away the thread. So let's see the results. This took 21 seconds, almost 22 seconds. Those are 2 XML files processed, and this is the amount of words which were counted, okay? Then I decided, okay, so, oops, I'm gonna go with 2 threads now, because I used only 1 thread. I said, okay, 1 thread, 22 seconds almost. 1 thread should take half of the time, right? In theory, or, the first thing that comes to your mind. So I decided, okay, same code, but here, instead of that's why I use 2 XML files. So I decided, okay, instead of 1 thread, I'm gonna create 2 threads. I'm gonna measure the time and count the words. First problem here, and here's my first tip. Sometimes when we're passing from a monothread solution to a multi-threaded solution, we think that by just, in this case, I saw here a potential issue. And sometimes we think, okay, so to convert that, I'm adding a new thread, and here I'm using a concurrent hash map, and everything should work because it's concurrent. As you remember, like in the other example, it was a normal hash map. I didn't need to synchronize everything because it was only 1 thread. So with this concurrent hash map, then what happens? This thing, there is a potential issue here with a race condition. So this is the first thing I saw. It's like, okay, why? Because this actually is not atomic. It's not an atomic operation, really. And so there might be 2 threads accessing or trying to access or using this method, and they're going to get different values, and we're going to end up in an inconsistent state within our map. So I said, okay. So this actually it's a Kotlin function, a merge. So you can actually it's pretty easy to use. But yeah, let's not get into details. And this is atomic, so it happens in only 1 cycle. So I don't need to care about that. But the tip here is like, don't think like that by just changing, for example, a collection which is concurrent, your problems are solved. There must be other part of your code that you need to keep in mind. So then I said, okay, let's see the results. 2 threads. Remember, 1 thread, threads and logs, 22 seconds, more or less. 18 seconds, or a little bit more. So that was only 3 seconds faster. And I'm adding, as we would say, like the double amount of power here, right? To process the same files and so forth. So then I said, okay, maybe I want to try other things, other libraries. And I said, why not RxJava? I think they have the power to introduce multi-threading by using schedulers. And this is my second tip. If you're going to use RxJava, I don't know how many people are using or aware or know RxJava here. Okay, and you use it in your projects, right, in your companies and so forth. Please don't use it only for the multi-threading part. because you might add a lot of overhead. I've seen or people approaching me saying like, okay, yeah, we introduce RxJava, and then I say, why? I don't know. It's because it's trendy, and because I know it's easy to add multi-threading, but you might end up adding a lot of overhead in other areas. So please use RxJava or any reactive framework or library when you need to compose many streams of data and modify and filter that data. So with that being said, it's super easy, as I said. You have only 2 methods, but let's not focus on this yet. To add multi-threading on RxJava. So let's see the results. I said, okay, so I'm going to start with 1 thread again, but by using RxJava, no threads and locks, pure threads and locks. So I said, okay, here, pretty much same code, hash map. I'm creating an observable. This is the way within RxJava, it's a monadic type, and you encapsulate a computation inside an observable. And so then you have to subscribe to that computation, that's a reactive part, in order to get all the emitted items by this. So yeah, anyway, so creating my observable, same thing. Here I'm saying, okay, log my data, and this is how I introduce threading in RxJava. So I say, execute this in this scheduler, which is single means a single thread. Same code here. So I said, okay, let's see the results. 21 seconds. It was even better actually than threads and logs. So then I thought, why is that? I mean, in the end, by checking the RxJava source code, then you realize in the end it's using threads and logs. Maybe it was my shitty code or something that I did wrong. I don't know. But anyway, I continue my research and I said, okay, let's use 2 threads in RxJava. If this is getting a little bit better, let's see what happens with 2 threads. And this is the code I came up with. Again, my concurrent hash map. And instead of having 2 observables, I have 1. And I'm subscribing to a new thread, each of those. Again, getting all the pages, looping through each page, counting the words, and putting everything in a map. See the results. Wow, that was faster. I mean, it's a second and a half faster than threads and logs, and I'm making progress. I said, okay, good. That's a good sign. Then I said, okay, let's take another approach. Let's see what is it like to do the same thing using Kotlin coroutines. So just a quick thing. Are you familiar with the concept of coroutines? Yeah? Okay. For those who are not familiar, coroutines is not, it's a language feature most of the time. Coroutines are, let's say, lightweight threads. Why lightweight threads? Because they're not mapping straight. One coroutine doesn't mean one thread. The threading model is usually handled by the operating system, in this case, iOS, Android, Mac, and so forth. Coroutines are, from many languages, and they're basically you can execute several coroutines with only one thread. So that's a good thing because you don't need to switch. The kernel doesn't have to handle that switching between threads and so forth. In order for this to work, actually, there is a lot of compiler magic. So there is, I'm not gonna get into details, but if you're curious about it, it's really interesting how it works. It works in a term within an approach which is called, I think, passing programming or passing computation. I don't remember, but it has to do with passing. So it has internally a state machine which is gonna come back once this coroutine is being executed. But anyway, just this is something that if you're curious about it, you can go deeper and deeper. So and the good thing about coroutines and why I decided to go with them is like you don't need to care much about like connecting threads and so forth, and you pretty much end up writing synchronous code in an asynchronous way. It's pretty easy to see. We'll see it now in an example. So I decided, okay, let's solve the same problem using Kotlin coroutines. Same piece of code, but using one coroutine with one thread. So I said, okay, here, my hash map, again, I'm gonna start counting stuff, gonna go to the counter. This is the way how you tell Kotlin to launch a new coroutine. So then you pass in like a block of code, whatever function you wanted to execute, and then, yeah, you get a result. So then I said, you can pass to a coroutine, and this works the same way, I think, in Clojure. There are this other language which provide the same functionality. You pass a context, and here my context is a single threaded. It's built in with Kotlin, so I don't need to care about it. And yeah, I'm counting the same thing. This is exactly the same pieces of code. So I said, okay, let's see the results. 21 seconds. Like I was being pissed off, you know. At some points, like, okay, I'm writing all this code and I'm not getting anywhere. So decided, okay, now I'm pretty much done with one coroutine. Let's do two in order to see if, you know, by chance something happens. So I decided, okay, two coroutines here. So I'm passing a context with two threads. And this is the way that you execute. As I said, like you can write code in a very asynchronous way, and it's going to be pretty much, it's going to execute another, not in the same thread. So it's going to launch another coroutine like in a very easy way. So basically you're saying like, yeah, just execute this piece of code asynchronously and give me the result. And this starts right away. So they both start in parallel. And then I'm telling the thread where this is being executed to wait until the results in order to continue. And that's when all this state machine under the hood is working. But yeah, those are implementation details. The only requirement here, just for the sake of information, is like you need to define what is being run inside a coroutine, like with a suspend function. And it's pretty much the same in every language that I've seen that introduces coroutines. So coroutines are a language feature, remember that, and threads and locks is an operating system functionality. So the same thing here, and I said, okay, well, pretty much the same. Let's see the first results. For some reason, RxJava, yeah, this is the font issue. RxJava was being faster. If you ask me why, I don't know. I tried, I look at the code, I'd run it using different versions of RxJava, different versions of coroutines. The good thing is like all these numbers can change, you know, depending on which version you're using. So then I decided, okay, so adding two threads doesn't have like a big impact. So what's going on then? Why I couldn't solve my problem? Why? Yeah, I could solve it, of course, but like it didn't make much sense to me. So then I started thinking, and this is the part that I wanted you to think about it. This is about threading, but also about problem solving. You know, how we start like solving a problem, you know, dividing the problem into smaller problems, and sometimes, you know, think about how to solve a problem. So my first hypothesis was, okay, so I need to do this better. Maybe my approach was not good enough. And my piece of code by just creating two threads and launching them right away is not possible. So I started considering maybe I should use some kind of well-known patterns like producer-consumer. Maybe one thread is producing some job, you know, in a queue, and then the consumer is grabbing those tags from the queue and executing them. Then I said, yeah, maybe split my problem into smaller problems, into smaller problems, and then why not? Could work. Reusing threads. Maybe I should use a pool of threads for some reason. I don't know. Things that come into my mind. And what about the collections? Maybe I'm using a concurrent hash map, but there's other things. There's hash table, or I could use the concurrent map wrapper, and pass in a hash map. Why not? So that's why I said, okay, oh God, but it says, analyze your problems, verify your assumptions. Because sometimes we are speculating and we say, we assume that things work in a specific way because we heard it, we read it, or someone told us. And sometimes we need to verify our assumptions and measure, and that's the way to go here. If you're dealing with performance, threading, measure, 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 and measure. And that was my first thing. So I decided, okay, I'm going to start with the concurrent collection. Maybe that's not the right one. I'm not using the right one. There's something which could be faster. So then I said, I grabbed my concurrent hash map here and said, perform some tests. And said, okay, so let's check them out. I said, okay, I'm going to use a hash table. I'm going to, get and retrieve 500,000 elements. It took like 1.5 seconds. The synchronized map wrapper took 1.5 seconds as well, and the concurrent hash map was way faster. So then I started thinking, so what's really going on? I mean, in terms of collection, I'm using the fastest one for solving my problem, right? The other thing was I started considering is like I'm parsing 2 files from disk. So input output most of the time is slower, and maybe my threads are being idle there waiting for disk, to read the data and give me the results. So that was my second hypothesis. So then I said, okay, here is where I'm parsing the XML. So I decided I need to measure that tiny piece of code. And said, okay, let's see what's going on here. Creating a page in memory, grabbing all the structure of the XML, nothing. Nothing for both pages, for both XML files. So then I said, parsing XML file, the parsing, like, when the parser grabs all the information and create the nodes and so forth, it was 4 seconds. And processing, once those nodes are in memory, it's nothing compared with this. So clearly here, so there's something going on with the input-output. And I said, okay, good. I'm getting some conclusions out of how I'm approaching this problem. And these were the first conclusions. So threads idle waiting, locking the map, maybe not. In the end, it was not a big problem. Then some feedback I got out of other developers, contributing to that piece of code is like something that I've never inspected. But just, parsing all those elements, in the case of Android, where we have a garbage collection, not for iOS, I guess, there was a lot of garbage collection activity because we were creating and destroying a lot of elements. I haven't double checked that yet, but I put it there because I wanted to remind me and remind it, and that was coming from feedback from other developers who were playing around the code. So again, then I said, okay, can we do better? Yeah, of course, we can do better. And again, all my ideas, coming again. So I said, okay, I'm going to do a better word count here. And I'm going to split up my problem into smaller problems. So then I said, instead of 2 threads, 2 coroutines, I'm going to use 4. So here's what's going on here. And that's why this number here. I'm just, creating ranges of pages. So for one XML file, I can read half of it, and in parallel half of the other. Then I said, maybe that improves something. And that's why I could create 4, and I could start 4 coroutines at the same time. And do you think this just like, quick question, some guesses here. Like, do you think this got better? Yeah? Okay. Let's check the results then. It got a little bit better, a little bit better. In the beginning I was like with you, like I thought I'm destroying this here. Even it's worse. Um, what was my conclusion here? Yeah, of course I created. I mean, I went from normal solution to a better one. I spent a lot of time then trying to think, to inspecting the code, rerunning it, different devices as well. But in the end, the results were pretty much the same. Changing versions of the libraries or the frameworks and so forth. So then I said, okay, can we do better? Yes, we can. But that's your homework, because at that point, someone called me and it's like, let's go for a beer and this. I'm done with this. I don't want to do this. So then I decided, okay, so contribution is it's important here. There is a conclusion behind all this, and I'm still working on the code. But these are some stuff that I was considering. Improve using threads and locks in my code, using coroutines. There's other ways to use coroutines. I don't know if the one that I used was the right one. And why not, like, grabbing stuff from other languages, from other approaches out there? Because that's what I've been doing over the time. We need to take lessons learned from other approaches. In my case, from backend, why not from Mac, from other things, and apply them. I've been playing around Clojure in order to solve the same problem, and then after 5 minutes I decided, no, this is not what I want to do. Probably I'll be end up like doing some Haskell, I don't know, out of curiosity, but I know some people who are using that. It could be a little bit challenging in the beginning. So that's why I always say, like, contribute to that, and if you're interested, we can get better at that. But on the other hand, like, while working on this code and on this problem solving thing, there's a bunch of specific problems which multi-threading bring up. So debugging is not easy, especially freezing the state and so forth. It's very challenging. There are some tools out there, but like logging and so forth, it could facilitate the process. Again, mutability, always a problem. Performance, I wanted to mention this because I always say, like, we shouldn't address performance unless it's key for our business. If we're developing a real-time system, then performance should be key, and we should tackle it. Otherwise, we can add a lot of complexity. And please, like, if you're gonna address performance, just measure. Not because someone told you, or some it happens to me, like, you're improving a code, this must be super fast or faster than the older version. And it's not true, because we haven't measured. So for me, this by knowing the fundamental parts, is like, it gives you more, I don't know, more solutions within our problem solving. It happened to me at some points. We were, while I was working at SoundCloud, we were having a lot of problems in terms of threading and in terms of how the player would work in order to cache the first 30 seconds of each track. So when playing the next track, you would have that, and we would launch, like, I don't know, 5 threads at the same time. And at some point there were some issues related to RxJava, and then the way to understand that is diving into the code, because there was no explanation, on the surface. You had to go deeper there, and you end up, like, if you understand, how threads communicate. I'm not saying that we need to become like threading experts, but because there's way more than I told you here. But at least that actually helped me to understand how things work under the hood, and gave me more solutions and more ideas on what was going on there. So my conclusions, my verdict is, basically, always use the right tool for the right job. And RxJava, I'm looking at you, or other reactives libraries. Measure. I want to focus on this. Please measure. Always measure. I know that sometimes, yeah, we want to do it something fast and so forth. But if you're really interested in improving performance, you have to measure. There's not any other way. And there are, of course, there are no silver bullets, and that's in my defense. The approaches I took here could always be improved, and always collect feedback and listen to that. So that's why I wanted to pretty much wrap it up with this. And again, what I showed you here is like my way to solve these kind of problems, but it's not something I would do in the first place, right? I would start like making my code work, make it clean, understandable and so forth, using good practices. And then when it's the time to make it a little bit dirtier, encapsulating functionality, which is complex, by measure, by improving performance, that would be something else that I would do afterwards. Something that I want to do going forward, it's like memory consumption. As I said, like I don't know what's going on regarding that garbage collection. It was told by a person I trust, and I haven't measured it. I'm against what I already told you to do. So then, out of curiosity, I wanted to explore really under-threading components in the end. I wanted to know if that makes things better or worse. Could be curious. And other external libraries, I know that Evernote has one. I think they're deprecating it, but it could be interesting. Then explore other technologies like iOS threading model. They have like this central dispatch, which is the way for adding multi-threading. Maybe that could be interesting to try to come up with some more ideas related to multi-threading. And maybe check out what is a server-side multi-threading like. I know there's attempts to use message passing through the actor model. I don't know if you're familiar with that. That's a way to add multi-threading. And other things, I think, like getting ideas and collecting feedback, it's very important here. And in our way to solve software engineering problems. So here's the repo. Please feel free to check it out and play around the code. Send a PR if you're interested. Again, as what I told you, the actor model could be interesting. I know a person who's working on this for Android. I checked the code, it adds some complexity, but why not? Then other functional programming languages, I know Clojure and Haskell has this concept of parallel collection, so maybe something related to the collection could be improved there, stuff like that. And again, to finally wrap it up, please do multi-threading only for this purpose. Responsiveness, to make a better use of resources, and simplicity, as we saw the last, with coroutines, code could be at least simpler. I think that's all I have to offer for now here. If you had any questions, you can follow me here on Twitter, my blog, or my GitHub, and other things. I'm going to be around as well, so any question is welcome, not only related to the talk, but other topics. I'm super always interested to talk about any software engineering stuff. And yeah, thank you very much for attending.